Good morning, class. This is Mr. Joshua Kitoto, who will be taking you in mathematics from 3 matrices today. Yesterday we talked about definition of matrices, the order of matrices, and the elements of a matrix. We went ahead and defined the types of matrices. Now today we want to talk about how to operate matrices, that is the addition and subtraction of matrices, then multiplication and division of matrices. To start with addition and subtraction, we must know that matrices can only be, the word only be added or subtracted if they are of the same order. Matrices with the same order can easily be added or subtracted. If they are not of the same order, we can't add or subtract. How do we add or subtract? The individual elements in a one matrix are added or subtracted to their respective elements in the other matrix, which means that if we have a matrix, there's an element in the first column, first row in one matrix, then the element in the other matrix in the first column, first row must be added to this element or subtracted. For example, we have given that matrices A 2, 1, 3, 5 and B negative 7, 8, 2, 0. Given, find matrix A plus B. That is our part A. And B, matrix B minus A. So in our solution, we will start with part A, that is A plus B. Our matrix A was 2, 1, 3, 5. B is negative 7, 8, 2, 0. Therefore, I said for us to add these two matrices, first of all we must consider that they are of the same order. As you can see, the first matrix A is in order 2 by 2 and B the same order 2 by 2. Therefore, it is easy for us to add them. How do we add? We must add the individual elements in the matrices. That is, our first matrix A, 2 is in the first column, first row. Therefore, we add it to negative 7, which is also in the first row, first column, which we have there. 1, first row, second column, added to 8, first row, second column. The same we do to 3, second row, first column. We add to 2, second row, first column, and then 5 added to 0. If you do so, we'll get 2 plus negative 7, that is negative 5. 1 plus 8, that is 9. 3 plus 2, we have 5. And finally, 5 plus 0 will give us 5. So this is our matrix. The sum of the two matrices gives us this. In the second example, that is now B minus A. The same will apply. For us to subtract the two matrices, first we must consider whether they are of the same order. A 2 by 2 with a 2 by 2. So we can subtract their individual elements in these matrices, which means negative 7 minus 2, 8 minus 1, 2 minus 3, 0 minus 5. If you do so, we get negative 9, 7, negative 1, and negative 5. That is how we subtract matrices. So we are supposed to know that matrices of different orders can never be added nor subtracted. Like we have this, our first matrix here, 1, 6, 10. It is in the order of 3 to 1, 3 by 1. If we add it to a matrix of order 2 by 2, it is impossible. Even if we subtract, we'll still get no answer. Therefore, it is in order to understand and not that matrices can only be added or subtracted if they are of the same order. Now for multiplication and division of matrices, again, we must know that matrices may be divided or multiplied if the first matrix has same number of columns as the number of rows in the second matrix. The same number of columns in the first matrix must be equal to those rows in the second matrix. We are going to understand that. And the same thing is done here. Individual elements in the first row of the first matrix are multiplied by individual elements in the first column of the second matrix. What I'm saying is this. Example, given that matrix A is 5, 0, 3, 1, 2, 4, and B is negative 7, 6, 4, 8, 9, 10, 2, 0, negative 3. Now we are being asked to find matrix A times matrix B. Matrix A, we have it here, and matrix B. So the first thing to understand is how do we multiply? When do we multiply? We multiply when the number of columns in the first matrix is the same as the number of rows in the second matrix. If they are the same, we can't multiply these matrices, and therefore, in our case, number of columns are 3 in the first matrix, number of rows in the second matrix are also 3, so they are the same, and therefore, we multiply this one. This our matrix A is a 2 by 3, matrix B is a 3 by 3, so we are going to have 5 times negative 7, we have negative 35. We add it to 3 times 8, that is 24, plus 2 times 2, that is 4. So that will be our first element in the first row, first column. We take the first row, multiply this first column. We are going to have that element. Again, we go to first row, second column. We must get this as well. We multiply as we add. 5 times 6, 30. 3 times 9, 27. 2 times 0 is 0. So this is our element in the first row, second column. Then first row, third column, we have it here. 5 times 4, that is 20. 3 times 10, that is 30. 2 times negative 10, that is negative 6. So that is, we are done with the first row. We are done with the first row because we have used the first row in our first matrix. So we are going to the second row, which again we take the second row, multiplies these columns. We are going to have 0 times negative 7 is 0, plus 1 times 8 is 8, plus 4 times 2 is 8. So this is now the element in the second row, first column is that. We go to element in the second row, second column, which should be here. So we are going to have 0 times 6 is 0, 1 times 9 is 9, 4 times 0 is 0. As we add, then finally we go to the element in the second row, third column. Second row, third column is here. We are going to have 0 times 4 is 0, plus 1 times 10 is 10, plus 4 times negative 3 is negative 12. If we add them, we are going to get negative 7, 57, 44, 16, 9, and negative 2. So this becomes our matrix. And as you can see, I'm bracketing my matrices. If you leave out the bracket, we will not consider this as a matrix. So matrices must be in brackets as we operate them. Then for the part B, we have matrix B times matrix A. As you have seen, matrix B is in the order of 3 by 3 and matrix A is the order of 2 by 3. When we multiply matrices, I've said the number of columns in the first matrix must be equal to the number of rows in the second matrix. So in our case, the number of columns in the first matrix are 3, while the number of rows in the second matrix are 2. Therefore, we can't multiply these matrices. Therefore, the multiplication is impossible. Again, we should now note that when you're multiplying or dividing matrices with their scalars, then the individual element in a matrix is either multiplied by the scalar or divided by the scalar. That one, we will look at that in our next lesson, plus how to get determinant and inverse. Thank you for the lesson.